For this video, we want to have an introduction to velocity time graphs, how they work and how to sketch them. So I'll have one drawn out here. Velocity. Let me just remove that. There's a VT graphs. On this axis we have velocity in meters per second, and here we've got time in seconds. There are a few key ideas that we need to learn about the velocity time graph. This is zero, obviously. Let's look at this. So for this graph, we're representing the speed that an object has. So you can just draw something and try to interpret something simple. So previously in displacement time graphs, we said that if you have a straight horizontal line, we said that means you're not moving. But if it's a velocity time graph, that's speed 20. Let's try to interpret what it would mean on this type of graph. It would mean that at time 1 you have a speed of 20. At time 5 you have a speed of 20. At time 9 you have a speed of 20. What does that mean? That just means that you're moving at a, or in other words, it means that your speed is not increasing or decreasing, or it means that your acceleration is 0. Acceleration 0. If it's a straight horizontal line, and that leads us to the first important point. The gradient of this graph shows the acceleration. So the gradient, if we look at that, the gradient is the change in y divided by the change in x. What's the change in y here? We're getting meters per second and we're dividing it by meters per second minus meters per second. That would be the change in y, because the y-axis is meters per second. The change in x would be in seconds. So our unit will end up being meters per second, and that is the unit for acceleration. And that's something quite important, the fact that the gradient here is acceleration. So if you have a constant gradient, that means a line, that means you have a constant acceleration. That's constant acceleration. This is constant acceleration. That is constant acceleration. But in addition, something important to see here is that we have a negative part and a positive part. What does this mean? We talked about this before. You can have a positive velocity and also a negative velocity. A positive velocity means you're moving maybe forwards in one direction, like that. And then the negative velocity might mean that you're now moving in the backwards direction. So if you're up here, you're moving forwards. If you're down here, you're moving backwards, or vice versa. Just make sure that they're in opposite direction. You could also be moving up, and then down here you could be moving down. The idea is that you're moving in opposite directions. What else is important to see? There's only almost one more important thing to see here. Well, maybe you could look more at the gradient idea. If you have a changing gradient means you have a curve, something like that, or that. Anything you would have, whatever type of graph you had, that's going to be a changing gradient. And the gradient on this graph is acceleration, meters per second squared. And that makes sense because we're measuring how much a speed is changing. If you have a very steep gradient, that means that your speed is changing very much. That means you're having big changes in speed. It's increasing a lot or it's decreasing a lot, like that. If your gradient is kind of low, that means that your speed is not changing much. Your speed is staying almost constant, almost consistent. You're moving at an almost consistent rate. Then the second most important thing to understand, unlike the displacement time graph, there is some information here that is kept in the area underneath the graph. So if you can calculate the area underneath the graph on this type of graph, there's some information that you can access. What information is that? Well, there's always one easy way to figure out what the area underneath the graph means. You could probably just draw a square, something like that. This side, the height, what will be the units? Well, that's on the x-axis, the y-axis. So it's meters per second. And then the x-axis is seconds. The formula for area is length times width, which will be meters per second times seconds. And when you cancel those out, you have meters. And that gives us some information, important information, that the area underneath this graph shows us a displacement. So the area underneath the velocity time graph is the displacement. How can you figure it out? If you multiply this by seconds, you get meters, which is the unit for displacement. So now there's something important to think about displacement. Just as we said, this downward part, the downward part shows negative velocity and the upward part shows positive velocity. That gives us some important information about the displacement. For example, if you had a graph that went like that and then like that, we're going to look at interpreting this later. We can look at the area underneath the graph, that's the area, but this area is above the graph. And then we have this area as well, but this one is below the graph. So what important information can we pick from that? Well, maybe if we're going to look at questions about this, but let's just think about it carefully. This up here, the car is moving forwards. So if the area up here is 8, that means maybe it has moved 8 meters forward at a certain speed. So the velocity rose, the velocity rose, the velocity rose, the velocity rose, the velocity peaked. So the velocity was at a maximum there. Then it's easy to think that on this part the car is moving backwards. No, the car is not moving backwards because it still has a positive velocity. It's like you're driving in your car, you're moving, you start at 0, then you increase to a speed of 5 meters per second. That's this part there. Then you increase to a speed of 10 meters per second. That's this part here, right there on the ascending. Then you increase to a speed of 15. Maybe that's your peak. Then you reduce your speed to 10 meters per second. Well, you're not really moving backwards, you're still moving forwards, but you're just slowing down. Then you decrease and then you're back to 0. When you're back to 0 meters per second, that's this location where it crosses the x-axis there, that's 0 meters per second. That means you've stopped. And then when your velocity goes negative on this negative part, that means now you're turning around and going backwards. So if the area here is 5, that means the area here 8, you had that area 8 when you were moving forward. So this forward movement, you moved 8 meters forwards. And then the area underneath the graph shows you moving backwards. So this area underneath the graph is like you're subtracting 5. And so you end up here at position 3 meters away from where you originally started, if you started at home. So those are the key ideas. The gradient is acceleration. So if you have a straight line, the acceleration is constant, like here, here, and here. Acceleration is constant. If you have a curve, the acceleration is changing. If you think about the area, it shows you the displacement. If the area is above the graph, it shows you the distance moved in a certain direction, positive direction. And if it's underneath the graph, it shows you the distance moved in the opposite direction from that. That's the key ideas.